Hello children, welcome to Zero Panic Maths. In this session, let us continue our discussion on finding out the nature of roots of a quadratic equation. Okay, so in the previous sessions of chapter 4, we have discussed that how to find out the roots of a quadratic equation, given quadratic equation by factorization method. Okay, so when we actually found out the roots of a quadratic equation by the factorization method, we used to follow some rule, that is splitting the middle term, right? But that method of splitting the middle term and finding the factors or roots of a quadratic equation will not always work, because if the roots are not factorizable, or the roots are not factorable, or the roots are irrational, then that method of finding the roots by factorization will not work properly. Okay, so because of that, we actually have one already proved formula for finding of the roots of a quadratic equation, and to decide what kind of those roots are, that is to decide what is the nature of that roots, this is the formula that we are going to use. Okay, so actually how did this formula is derived is not part of your syllabus, but anyway, we are going to see. I will explain that how did you got this particular formula, minus b plus or minus square root of b square minus 4a divided by 2a. How did we got this formula? Okay, I will explain you that steps, but that is not part of your syllabus. Okay, and after discussing this formula, we should be concentrating on the three different roots and the three different natures of the quadratic equation. What are those natures? Okay, it is based on the quantity b square minus 4ac. Given the equation ax square plus bx plus c, a, b, c, take the values of a, b, c which are real numbers, and find out the value of b square minus 4ac, and that is called as discriminant. Okay, that value, that quantity b square minus 4ac is called as discriminant. Okay, and based on that value, discriminant, whether it is greater than 0 or it is equal to 0 or whether it is less than 0. How do we decide that? If it is greater than 0, then the roots are distinct and real. If that quantity is equal to 0, simple, again the roots are real, but the roots are equal. They are not distinct, they are equal. If there are two roots, both their roots are equal to each other. And finally, if that quantity b square minus 4ac, the whole value, is less than 0, then the roots are not real. If not real, we can call them as imaginary, or you can directly say that the equation has no real roots. Okay, we will see some of the examples of those also. Okay, then I think you understood what exactly is the nature of the root. Okay, let us see this. How did we got this formula minus b plus or minus b square minus 4ac divided by 2a? This is a formula for finding out the roots directly without factorization, remember, and the method of deriving that is called as method of completing the square. Okay, completing the square. Let us quickly see that how did we got that formula minus b plus or minus square root of b square minus 4ac, where b square minus 4ac, this part is actually discriminant or d, and divided by 2a. Okay, remember that. Okay, let us see. Okay, let us keep this formula and let us derive that. Okay, okay, now let us consider ax square plus bx plus c is equal to 0 and start deriving that equation, where we will find one formula for x. Okay, now first of all, first step is divide the given equation by a, so that I will have the coefficient of x square as 1. Okay, so first step one, you can say divide by a. Divide by a will actually give us a x square divided by a plus bx divided by a, okay, plus c by a is equal to 0. So a got cancelled. Okay. So let us keep x square plus bx divided by a or b by a into x and take c by a to the right side. Okay. So that is x square plus bx by a is equal to minus c by a. Okay. Now is the very important step. So that is what we are saying, that it is the method of completing the square. So out of the given two terms at the left hand side, listen to me this carefully, this step. Okay, out of the given two terms in the left hand side, we are actually making it a complete square of the form a plus b whole square. Now, what is the formula for a plus b whole square? It is a square plus 2ab plus b square. Okay. So, let me write the b by a into x with little bit of adjustment. I'll tell you what exactly is that. Okay. So, I will adjust this as, okay, x square plus, I am writing the term 2ab. Okay. So, let x be a. Okay, so 2 into x, so I'm writing x here, and it is b by 2a. You got this? You see, 2 will get cancelled, and what remains is bx by a. Bx by a. So bx by a only will remain here. 2 will get cancelled. So I did not done any modification to this value, but I have written it in the form of 2ab, where a is x and b is b by 2a. B is b by 2a. So let me add that part also here, b by 2a. Considering b as b by 2a, I will add the square value of that, so that, remember, so that I will get a square plus 2ab plus b square. B is b by 2a. Okay. So since I have added this term b by 2a whole square to the left hand side, I should be adding that to the right hand side also, just to make or to maintain the equality of the equation. Okay. So let me add that, the whole term b by 2a whole square minus c by a. Right. I've added that term also here. Okay. Now, as I already told, why did I extended this term? Because I want this to be completing the square. This whole left hand side, I want it to be in the form of completed square. What is that? X plus, what is this? A square plus 2ab plus b square is a plus b. What is b? B by 2a is my b. So is equal to, so whole square, it is a plus b whole square. Right. So let me write b square, okay, and divided by 4a square. Square of 2 is 4, square of a is a square, minus c by a. Minus c by a. Okay. Now let me take the LCM of 4a square and a and extend this term alone. Okay. Okay. Let me write that. Okay, listen to me this step. So what will be my LCM is 4a square. So for 4a square, it is 1 and since there is 1a already here, so I should be multiplying this by 4a to get 4a square, right? 4a is a into 4a square, that is LCM. Okay, so what is this? B square into 1 is b square, 4a into c, that is 4ac. B square minus 4ac. And what is this equal to? Is x plus b by 2a whole square. Okay, now I'm taking this square to the right side. Okay, the square to the right side. If I am transferring the square to the right side, it will give me plus or minus square root of this whole term. Okay, so next step, let me write that step. X plus 2a, sorry, x plus b by 2a, taking the square to that side will actually give me plus or minus square root of the above term, b square minus 4ac, b square minus 4ac divided by square root of 4 and square root of a square. Let me write them separately so that I will get the exact value. I'll get the exact value. So square root that actually taken from the left hand side, I have splitted them into the numerator and denominator separately at the right hand side. That is what I did. Now let us transfer, or let us first reduce the terms. B by 2a, keep it as it is. And what is this? Plus or minus b square minus 4ac, there is no change into that. Okay, and divided by square root of 4 is 2, and square root and square got cancelled, and what remained is 2a. Fine. Okay, now take plus b by 2a to that side will actually give me minus b by 2a plus or minus as it is, plus or minus square root of b square minus 4ac divided by 2a. So 2a is LCM on these two terms. So if I've taken b2a as the LCM, then what remains here is minus b plus or minus as it is, and this is b square minus 4ac, and this is what the formula that we actually saw. Okay, so remember this formula to find out the roots of a quadratic equation directly without factorization. We need to make use of this formula. Okay. Let us see the examples based on the discriminant. Okay, so let us see some of the solved examples. Okay, find the discriminant of the quadratic equation 2x square minus 4x plus 3 is equal to 0. See, you might be thinking that since we already have a factorization method, then why do we require this formula? I'll tell you that reason. I already discussed that, but you can see that now. You see, 2 3s are, it is 6, right? 6x square, and what is the sum we want is minus 4x. So is there any factor that gives me this? The product should be 6 and the sum should be 4, because 4 has only two factors, 4 ones are 4 and 2 twos are 4, right? So with both 4 ones are 4 and 2 twos are, can I get the product as 6? No. So there is no possibility for sum of the quadratic equation. There is no possibility of finding the proper factor so that I can split the middle term. So that is the reason that we are using that formula. Let us find out the discriminant. Given with the given equation, what is a? B. B is minus 4. C is 3. Let us write a, b, c, because we need a, b, c only from that. Okay, now find out the discriminant. What is that discriminant? D is equal to b square minus 4ac, because based on the discriminant only we are going to decide the nature of the roots. Okay, okay, so what is b square? B is minus 4 square minus 4a. What is a? 2. What is c? 3, right? It is 16. Okay, minus 4 into minus 4, it is plus 16. Okay, minus 4 8s are, sorry, 4 2s are 8, 8 3s are 24, and what is this? It is minus 8. So we got the discriminant value less than 3. We got the discriminant value as, sorry, less than 0. Then what is the nature of the root? There are three conditions. You remember that? There are three conditions. If it is greater, then it is real and distinct. If it is equal to 0, then it is real but equal. If it is less than, then the roots are not real. Okay. Therefore, the roots of the equation, since we got the discriminant value, we don't have to find out the roots because we are not going to get the real roots. That's why the roots of the equation, are not real. You can write that. Done? Yes. Okay. Let us go to the next problem. Let's read the description. A pole has to be erected at a point on the boundary of a circular park. Okay, there is a circular park. We have to imagine a circular park of diameter 13 meters. Diameter of that circle is 13 meters. And we have to erect a pole on the circumference or the boundary of a circular park. Boundary is actually the circumference of the circle. In such a way that the difference of its distances, okay, the difference of distances from two diametrically opposite fixed gates A and B. Fixed gates A and B. So our diameter for that circle is AB. Okay. On the boundary is 7 meters. Okay, let me just draw that circle and explain the situation, and you will be easily getting it in that possible. So they are saying, is it possible to do so? Is it possible to erect that pole with the given situation? That is first question. If yes, then what distance from the two gates should be the pole be erected? Okay, let me first draw that circular diagram. Let me take the circular shape, okay, and draw this. Okay, select it and bring it down. Okay, this is the circle. Okay, and what they are telling is diameter is 13 meters. Okay, then let me write draw the diameter also. Okay, suppose this is diameter. Okay, so if that is the diameter, then what they are saying, that is A and B. And what is this? 13 meter they have given. See, boundary of a circular park of diameter 13 meters. Okay, now in such a way that the difference, okay, that we will see, but again they have given that diametrically opposite fixed gates A and B. There are gates A and B diametrically opposite, right? Okay, then they want a point on the boundary of a circular park. Okay, let us suppose this is that point. Okay, they want to erect a pole here, okay, on the boundary only, in such a way that the differences of its distance from two diametrically opposite gates. So this distance, suppose this distance and this distance, okay, they are saying the difference is 7 meters. Difference is 7 meters. So suppose they are saying this is x. If this is x, then it will be x plus 7, right? Because the difference is x. Sorry, difference is 7. So we can say that this is 90 degree. Okay, and let us call the point, this point, as P. Let me write, let BP, okay, I am considering the point P. Let BP is equal to x. Distance, let distance BP is equal to x. Okay, and what they have given is what they have given. So I can say this is 7. Since BP is already X, okay, I'm trying to find out AP, right? AP is take minus BP to that side will become BP plus 7, and that is equal to X plus 7. Okay. So that is the reason I already written AP as X plus 7. Now you understood? Okay. Now with Pythagoras theorem, we need to find out that equation first, right? Okay. By when there is a right angle triangle, we should go for the Pythagoras theorem. Okay. By Pythagoras theorem, what Pythagoras theorem says that hypotenuse square is equal to the sum of squares of the other two sides, base square plus the altitude square. Okay, so that is BP square plus AP square is equal to AB square. That is the diameter, or you can say hypotenuse of the right angle triangle. You understood? Okay. Now let us put BP is equal to X, which is X square. And what is AP? AP is X plus 7. X plus 7 whole square is equal to, what is AB? They have given already, that is 13 square. Right? So that is X square plus, this is A plus B whole square. A square plus 2AB plus 2A and B plus B square, that is 7 square, 49 minus, okay, or else I will write the square of 13 first, 169, right? Okay, and what is this? Is 2x square plus 2 into 7, that is 14x, okay, plus 49 minus 169 is equal to 0. Okay, now let me write that part to the next slide. Okay, remember this part, 2x square plus 14x. So 49 minus 169, that will be actually minus 120. Let us write that to the next slide. So what did we got is 2x square plus 14x, right, and minus 120 is equal to 0. Is that what we got? Is it correct? 2x square plus 14x plus 14, 9 minus 169, that is minus 120. Let us divide this by 2, okay, or else I'm taking 2 out of this and taking to that side will actually give me x square plus 7x minus 60 is equal to 0. So this is my equation. First of all, I derived the quadratic equation. Now we need to find out the discriminant and check whether the roots are real or not. Okay, if the roots are real, then this situation is possible. Our first answer, we got the answer for the first equation. Then the second part is to find out the actual values of the roots. Okay, okay, now let us find out the discriminant. Now discriminant d is equal to b square minus 4ac. Okay, so what is b square? B is, what is b here? Is 7 square, right, minus 4, what is a is 1, and what is c is minus 60. Okay, multiplied by minus 60. Okay, then what is this? 7 square 49, minus into minus, this is plus, 4 into, or 60 4s are, okay, that is 240, and what is this? 289, which is greater than 0. Okay, since 289, which is discriminant, is greater than 0, so if the discriminant value is greater than 0, then what is the nature of the root? That the roots are real and distinct. You're going to get two distinct roots and roots are real. If the roots are real, then the first question, is this situation possible? Yes, this situation is possible. Therefore, the situation is possible. The first part we write situation is possible. Right? We have solved the first part. If the situation is possible, if yes, then what did they told? What distance from the two gates should the pole be? Then we should be finding out x. Okay, so from the previous slide we should be finding out the x, so that we can get x plus 7, and uh, this distance bp and this distance ap we should be finding out. That is what our intention is. You understood this point? Okay, now let us find out the roots by using that formula. What is that formula? Remember that x is equal to, let me write that here, minus b plus or minus b square minus 4ac divided by 2a. Okay, please keep this formula in your mind. Okay, okay, now let us write x is equal to minus b. What is b? B here is 7, so that is minus 7. Okay, plus or minus square root of, what is b square minus 4ac? Don't calculate it again, because we have already found out that is the discriminant, the quantity inside the square root, that is 289. Okay, that is square root of 289 divided by 2 into a. What is a? A is 1. Okay, that is 2. Okay, so the what are the two roots? What are the two roots here? Is minus 7 plus square root of 289. Okay, or else I can write, what is square root of 289? What is square root of 289? That is 17. 289 is 17 square. That's the reason. Okay, divided by 2. Okay, and minus one root is with plus and another root is with minus. There are two roots. Okay, I'm splitting that. 7 minus 7 plus this root, minus 7 minus this root. Okay, this is the second root, that is 17 divided by 2. Okay, therefore x is equal to, what is this value? 17 minus 7, that is 10 by 2. X is equal to 5 is one root, and another is, it is minus 24 divided by 2, that is minus 12. So the two roots are, the two real and distinct roots are plus 5 and minus 12. Again, since x we considered it as a distance from point B to P, it cannot be in negative. Okay, so since x is distance, ignore the negative value. You can say ignore negative root. You can say ignore the negative root. Okay, it is not f, huh? It is ignore the negative root. Ignoring the negative root, what is the other value of x, which is positive 5. Therefore, distance BP is equal to x and AP. What is AP? AP is equal to x plus 7. Right? What is x we considered is 5 meters, and what is x plus 7 is 12 meters. This is the solution for that problem. Okay. Now let us move to the next problem. Okay, again we need to find out the discriminant for the given equation and find out whether the roots are real, okay, and distinct, or real or equal. Okay, find them if they are real. Okay, let us write that equation. What is the equation? Equation is 3x square minus 2x plus 1 by 3 is equal to 0. Let me write a quickly. A is 3. What is b? B is minus 2, and what is c is 1 by 3. Okay, let me first of all find out the discriminant. What is the discriminant? Quickly, b square minus 4ac, the quantity inside the square root. We need to find it out. Okay, what is b square? Is minus 2 square minus 4a is 1 and sorry, a is 3, a is 3 and c is 1 by 3. 3 got cancelled here, and what is this? Is 4 square, sorry, 2 square is 4 minus 4, which is equal to 0. So if the discriminant is equal to 0, then the roots are real but equal. Okay, therefore the roots are the roots are the roots are real and equal. But what are those equal roots? We have to substitute the value of a, b, c into that formula, minus b plus or minus. Okay, that formula we need to find it out. Okay, the second part is to find out the exact roots. Okay, let me write that. Okay, again you should remember that formula, minus b. What is minus b? Minus of minus 2, because b is already minus 2. So minus b I'm writing, plus or minus square root of, what is discriminant? 0. Square root of 0. Discriminant value b square minus 4ac, we already know that this is 0, divided by 2a. A is 3 to a. So what are the values? What are the two distinct roots for me? Is x is equal to minus of minus, that is 2 minus square root of 0. Let me consider that as 0. Okay, then it is 6, right? And 2 plus 0 divided by 6. These are the two different roots. Okay, so what are the actual roots? X is equal to 2 by 6, that is 1 by 3, and 2 by 6, that is 1 by 3. So 1 by 3, 1 by 3 are the two real and equal roots. Okay, now you understood what is the nature of the root. Since the discriminant is equal to 0, we already know that if the value is equal to 0, then you are going to get two real and equal roots, and those roots are these roots. Okay, so this is how we are actually deciding the nature of the uh, roots of a quadratic equation based on the discriminant value. Okay, so let us stop our discussion here only. We have seen some examples and the derivation of the formula for a quadratic equation, finding out the roots of a quadratic equation. Okay, let us discuss the exercise problems 4.3, which are also the similar examples that we will discuss it in the next session. Okay, thank you.